Hey, welcome back to Andrew and I'm on Deep, the show where I appreciate Mr. Butar's raw passion. Today we're going to be taking a look at antiderivatives and integrals, basically. So we're all familiar with the concept of the derivative, d over dx. We're taking the derivative of, say, a function f of x, right? The derivative of f of x, we're all familiar with the differentiation rules. Remember, we have addition, subtraction, product rule, quotient rule, chain rule, and all that. But the question arises is what happens when we do differentiation backwards, where instead of saying, okay, I'm given a function f of x, and let me differentiate this into something, right? What if, but the question is, I have what if I'm given the result, so we'll call the result g of x, but we don't know what we're differentiating. How do we find this? So as you may have guessed, we use the process of finding the antiderivative. So whereas this way would be looking for the derivative, going backwards from g of x to this question mark, would be finding the antiderivative. This makes sense, hopefully. Okay, so this is easier said than done. How do we find the antiderivative? Well, just like differentiation, there are a few rules that can help us to work backwards. Maybe let's start out with a couple properties of this. So instead of leaving this as a question mark, let's get rid of this top part. And let's define this more rigorously. Let's say this is f of x right here. So the derivative of f of x is g of x. And let's say we are given g of x, okay? And we are looking for f of x. Okay. So this can be rewritten using something called the integral. So the integral symbol is basically a really elongated s that looks like that. I've drawn that very poorly. Let's do that again. There we go. So it doesn't look too much like an s, but it's just kind of really long. And we say that the integral of g of x, remember we need to have the with respect to x. So we leave the dx here because we're integrating with respect to x. It's the same idea as differentiating with respect to x. We need to make sure we have this dx over here. And this will be equal to f of x. Sorry, I've drawn the bracket the wrong way. There we go. So we can say that these two are equivalent. In here, we know that the derivative of f of x is g of x. And conversely, if we were to take the integral of g of x, which is the antiderivative of g of x, we get to f of x. So that's great. And the question arises, how do we do this? Well, there's a few. Let's start out with reversing the power rule, right? We're all familiar with the idea that if we have, let's write this down, power rule. We're familiar with the idea that if we have x to the n and we were to take the derivative of this, as long as x is a constant, as long as n is a constant, we are left with n times x to the n minus 1. So it follows that if we were to work our way backwards, what's the integral of x to the n? So take a moment and pause the video and see if you can try to guess what this might be. Okay, well, so if you've guessed it, congratulations. The idea is we want our exponent to be n plus 1. And this is because when we take the derivative, we will subtract 1 from it, and that will lead us to this x to the power of n. However, when we take the integral of this, we're also left with an additional coefficient of n plus 1 when we take the derivative over here. So, to get rid of it, we're going to divide the whole thing by n plus 1 as well. And this is essentially the power rule, but backwards. Let's put this to an example. Suppose I want to find the integral of x to the power of 5 with respect to dx. See if you can figure this out. We'd start out by finding the exponent, which would be 6, because we're going to subtract 1 to get to 5. Now, if we take the derivative of just this, we'll be left with a 6 as a coefficient, which is no good, because there's no 6 here. So we're going to divide our expression by 6, the same idea as what we did over here. So this is Almost done, but we need to remember, whenever we take the integral, we need to add an indefinite integral, which has no bounds. We need to add a plus c, the integrating constant. Because if you think about it, there's an infinite amount of functions of this form that actually satisfy this. Because they all have the same slope at the same point. Some of them are just shifted up and down a bit, but they still have the same slope and they still have the same derivatives then. And so we need this constant plus c to tell us that, okay, well, we're referring to a whole family of functions here, not just this one specific one. But yeah, so that's essentially how we do power rule backwards when we're looking for integrals. Join us next time when we talk about addition and subtraction rules, as well as the constant multiple.